Okay, this video is for Unit 7, Topic 1 homework, and this is Part 2. So for number 9 here, the first thing I'm going to find is AB. So I'm going to use Pythagorean Theorem. So it's going to be 8 squared plus 5 squared is equal to AB squared. Okay, this is 64 plus 25 is equal to AB squared. Here we get 89 is equal to AB squared. Square root both sides. And here we get 9.4 is equal to AB. Okay, there's AB. Now we just need to find angle A and then angle B here. Okay, so let's start with angle A. So right here, angle A, this would be opposite. This would be adjacent. Okay, so that's tangent. So I'm going to have tangent of A is equal to opposite over adjacent. Okay, I want to get A by itself, so I'm going to use the inverse, which is inverse of tangent. Inverse of tangent of 5 over 8. Now I can plug that into my calculator. Angle A is equal to, so we use the inverse of tangent of 5 divided by 8 equal to, we get about 32 degrees for that one. Okay, so there's angle A. Angle B. Okay, is right here. Well, now these flip. So now 8 becomes the opposite. 5 becomes the adjacent. So it's going to be the opposite. So here, I'm going to have the tangent of B is equal to 8 over 5. Use the inverse of tangent again. We get B is equal to the inverse of tangent 8 over 5. Plug that into our calculators. We get about 58 degrees. Okay, so there's number 9. Number 10, so we have to find this side, and this angle. So let's find angle A first. So remember, angle A plus this 90-degree angle plus angle B, they all must add up to 180. So I'm going to take 90 plus 31, okay, which is 121, and subtract that from 180. So I get angle A is equal to 59 degrees. Okay, so we got the first one. Now let's try to find BC right here. So if this is the angle I'm going off of, this is opposite, this is adjacent. Okay, so this is BC. So I'm going to use tangent. So I'm going to use tangent of 31 is equal to the opposite over adjacent, which is BC. Here I want to get BC by itself, so I'm going to start by multiplying BC over. So now I have BC times the tangent of 31 is equal to 4. BC is still not by itself, so I'm going to divide by tangent of 31. So now I have BC is equal to 4 over the tangent of 31. Plug that into our calculators. So 3 divided by tangent of 31. And we get about 5. So BC is equal to 5. Right there. Okay, and then the last one, AB. So now, using the same angle, now this is opposite over hypotenuse, so that's going to be sine. Sine of 31 is equal to 4 over our hypotenuse, which is BA. Follow the same process as the last problem. We're going to try to get BA by itself. So we have BA times sine of 31 is equal to 4. Divide by sine of 31. And I have BA is equal to 4 divided by the sine of 31. Plug that into our calculators. We get BA is equal to 7.8. Boom. Okay, so there are our 3 answers for that one. Okay, number 11, we want to find the secant of theta, and we're given this triangle. Okay. Well, let's remember that secant is just the reciprocal of cosine. So let's find the cosine first, and then we'll just flip it at the end. So here's our theta, so this is opposites. This is our adjacent, and here's our hypotenuse. So remember, cosine is adjacent over hypotenuse, so we have 12 over our hypotenuse. Well, we need that hypotenuse, so let's use Pythagorean Theorem to find it. So we're going to have 12 squared plus 16 squared is equal to, let's just call this x squared. Okay, so we're going to try to solve for x here. So we're going to have 12 squared plus a 16 squared gives us 400. Is equal to x squared, square root, we get 20 is equal to x. So now we know our cosine of theta is equal to 12 over 20. Okay, and we can reduce this down to 3 over 5. If we put a 4 into both of those. Okay, but we're not asked to find cosine, we're asked to find the secant, so we just take the reciprocal. So secant of theta is equal to 5 over 3. There's that one. Okay, number 12, cosecant of theta we need to find. So cosecant is just the reciprocal of sine. So let's find sine first, and then flip it. Well, to find sine, we're going to need this hypotenuse. So let's call this x here again. So we're going to use the Pythagorean Theorem. So we're going to have 7 squared plus 4 times the square root of 11 squared is equal to x squared. Okay, so we're going to solve for x here. Okay, so here we get 225 is equal to x squared. That gives us x is equal to 15. Our hypotenuse is 15. Okay, so the sine of this triangle is opposite right here, 7, over hypotenuse, which is 15. But we need to find the cosecant, so we're just going to flip that. 15 over 7. There we go. There's our answer for that one. Okay, moving on. So number 13. So for number 13, we're asked to find the cosine of theta, this triangle. Well, if theta's here, this is our opposite. This is our hypotenuse. To find the cosine, we need that adjacent side, though, so we need to solve for this right here. So we'll have x squared plus 4 times the square root of 3 squared is equal to 8 squared. Here we get x squared plus 48 is equal to 64. Keep solving for x. We get x squared is equal to 16. X is equal to 4. Know that is equal to 4. Okay, now we need to find cosine of theta. So cosine of theta is going to be adjacent over hypotenuse. We have adjacent, which is 4 over 8, is equal to 1/2. Done. Okay, number 14, we need to find the secant of theta. So remember, secant is just the reciprocal of cosine of theta. So let's find cosine and then flip it. So here is our adjacent, here is our opposite, and here is our hypotenuse. Well, for cosine, we need that hypotenuse. So let's find it. So we're going to have 4 squared plus 2 times the square root of 21 squared is equal to x squared. So now we need to solve for x. Here we get 100 is equal to x squared. So that means x is equal to 10. So our cosine becomes our adjacent over hypotenuse, so 4 over 10. Secant, we just take the reciprocal of that, 10 over 4. We can reduce this to 5 over 2. There's our answer for that one. Okay, moving on, number 15. Find secant of a if c is equal to 21, a is equal to 6 times the square root of 10. Okay, so let's draw a triangle first. And in the directions, it says the right angle is C. So we'll label that C, A, and B here. Okay, well, C is right there. A is right there. Okay, and we're asked to find the secant of A. Okay. Well, first, let's find the cosine, because secant is just the reciprocal of that. So let's just find the cosine first. Okay, well, cosine is adjacent over hypotenuse. So if this is our angle, here's our adjacent side. Shoot, we don't have that side. So let's find it. So we're going to have, we'll call this b. So we'll have b squared is equal to, or plus, 6 times the square root of 10 squared is equal to 21 squared. Okay, so now we just need to solve for b here. So we can plug some of these into our calculator. This gives me 360. This gives me 421 plus b squared. Okay, continue to get b by itself. So I'm going to subtract over that 360. B squared is equal to 81. Then square root both sides. That gives me 9. B is equal to 9. Okay, so we know this is 9. So that means the cosine is 9 over 21. So the secant is just the reciprocal of that. So secant of A is equal to 21 over 9. We can reduce that, simplify it. We get 7 over 3. Is our answer. Okay, number 16. Let's draw our triangle first again. Okay, here's an C, A, and B. Okay, A is right here, C is right here. Okay, and we're asked to find the cotangent, but let's find the tangent first because cotangent is just the reciprocal of tangent. So the tangent is adjacent, or sorry, opposite over adjacent. So if our angle is right here, this is our opposite. Here's our adjacent. We need that adjacent side. So we're going to use Pythagorean Theorem. So b squared plus 9 squared is equal to 3 the square root of 13 squared. Okay, now let's solve for b.